Lovins, and Leidy, Klotz, and I will have the pleasure of your company talking about design and the power of less. Leidy has taken an unusual trajectory, turning from an engineer into a behavioral scientist, as he discovered and explicated a previously undemonstrated human bias, which he will now explain, starting perhaps with how he learned it from his 6-year-old, who had the advantage of child mind. Leidy?
Yeah. So same Legos here. I turned around behind me to add a block to the shorter column to make the level bridge. And by the time I had done that, but before I had done that, Ezra had removed a block and made the level bridge. And so right there in front of me was this thing that I'd been interested in, and again, always interested in minimalist design, design for the environment. How do we create a world that allows us to make progress and also respect planetary boundaries? But this really narrowed it down to, okay, why don't we think of subtracting as a way to make things better? And I guess I'll segue into a couple of the more convincing studies, and then we'll go into the conversation. But obviously, bridges with a 3-year-old don't necessarily make for a convincing argument. So our next study was way more serious. We used the stormtrooper setup here, and what we wanted to do was show that, okay, I mean, the argument you can make with the bridge is it's the same, right? If you add to make the level bridge, you subtract to make the level bridge. It's one act, and so it's basically the same. It's not better or worse to add. So we wanted to create something where it was obviously better to take away, and that may see if people still missed it. And so this stormtrooper sandwich, the challenge people had was to put a masonry block on top of the Lego structure there and still protect the stormtrooper. And if you put it on there as it is now, there's not enough support. The top will collapse and the stormtrooper gets hit by the masonry block. And the additive solution that most people did was to put a ring of Legos around the top there. So basically fill in the top layer. The subtractive solution is to take away the block in the back corner there, move the platform down. It still has enough clearance for the stormtrooper, and you do this in the minimal amount of moves. And we asked people to do it in the minimal amount of moves. We asked them we even incentivized them, if it costs money to add blocks, it doesn't cost money to take blocks away. And people missed it. And so what's going on here is the same thing that's happening with me with the Legos. Is our first thought is, hey, what can we add? We think, what can we add? It solves the problem, or we think it solves the problem, and we move on without ever considering subtraction in the first place. And we did a lot of studies. We did 18 studies. Here are some of them. It's important to note this is happens in the physical world, also happens in ideas, right? Ideas, writing, schedules. You can notice yourself overloading your schedules, forgetting to take things away. But all of these things are specific cases. And the last study I'll leave you with, and then we'll go back to Amory, is what I think is the most convincing one, because it's context independent. We gave people these symmetry puzzles and said, what's the simplest way to make this design symmetrical from left to right and top to bottom? And as you can see here, now that you've been cued with subtraction, you realize that the simplest way is to remove the blocks in the upper left corner. But most people would add blocks to 3 corners. And so what's happening here again is this same thing that happened to me with the Legos. We think adding first, and then we move on without even considering whether subtraction might be better. So like Amory aptly characterized it, it's just a bias in the human decision-making process that once we know about it, we can start to think of ways to do better and to take advantage of the fact, quite frankly, that we have had this bias for so long. So there's a lot of untapped opportunity with subtractive design.
Where do you think this comes from? And let me just point out, it seems a rather deeply seated bias in the adults you worked with in your experiments. You know, if you gave them a chance whether to fill in squares on graph paper or to erase it, they were biased towards adding, not erasing. And if you pointed out they had an eraser, or you would even perhaps charge them for filling in and credit them for erasing, the bias was still there, as I recall. Is it something like that? And you did a paper in Nature about this, which got quite a lot of attention. There was a beautiful write-up of it in The Economist, because people hadn't realized there was this pervasive bias toward adding stuff instead of taking stuff away. So how has this evolved as you do your experiments and get the reaction of people to whom you point out this bias?
Yeah, it's one of those, it has gotten, I think, more attention than any psychology finding last year, at least, and was on the cover of Nature. Is not something that happens to me often. And that's how I got to meet you. I had seen you talk, but then you reached out having diligently read Nature, apparently, and saying, hey, this is cool and it applies to the design that you do. I mean, the reaction has been kind of, hey, this is, yeah, that makes sense. And I think the key new part, right? I think everybody knows we don't subtract as much as we add, or especially once you think about that a little, but also the fact that we don't even think of it, right? I think there are a lot of reasons why you might not think of subtract, why you might consider subtracting and then decide against it, right? There's economic forces pulling us in that direction. There's social forces pulling us in that direction. But the fact that we're not even thinking of it is a basic problem, and also hints that this is like a bigger issue, or a more deep-seated issue than just, oh, this is capitalism causes this, right? Or this happens because of some, modern incentives that are making people more likely to add than subtract. I think biologically, there obviously this need to acquire food is something that's additive. The other thing that's surprisingly biological is competence, right? So this desire to show that we can interact with the world. And this is something that bowerbirds do. They build their fancy nests to impress mates. And there's no shelter function of those nests. Now, we as humans share the same desire to show that we can interact with the world. And it's a lot easier to show that we can interact with the world by adding than by subtracting. When you subtract something, it's, by definition, not there.
Which means you can't see it, as Roy points out. And this is a little bit like the challenge we have in trying to get folks interested in energy efficiency. Well, yeah. Energy is invisible. The energy you don't use is almost unimaginable. It's so much easier to add supply than to improve efficiency and reduce demand. And in fact, the US is now using 60% less energy to make $1 of GDP than it was in 1975, but who noticed?
Right. Yeah, I think that's the best. I mean, obviously there's no single reason for any behavior, but these reasons reinforce each other, and the visibility combined with not thinking of it is a really powerful reinforcing feedback loop. So basically, you're less likely to think of adding, or you're less likely to think of subtracting. That leads to being less likely to subtract. And then the rare cases where you do subtract, so all of your work with energy efficiency since 1975 that's had these amazing effects, it's invisible, whereas the solar panels, also good, but an addition, are sitting there visible, and people are reminded that addition is a way to make the world a better place. So I think that's the reinforcing feedback loop that subtraction is fighting against, and really is a good explanation for why we've gotten to where we are, not just overlooking subtraction, but also with a planet that has more human-built stuff than biomass now.
I've been struggling with the invisibility of energy efficiency as I try to figure out how to get more people interested in it. And I keep bumping into verse 11 of Adjunct, whose classical name in the old impossible translations is the use of what has no substantive existence. And it goes something like this: 30 spokes connect the wheel's rim to the hub, but it's the axle hole in the middle that makes it useful. The potter shapes the clay vessel, but it's the emptiness within that makes it useful. The carpenter hews the house's walls and windows, but it's the empty space in the room that makes it useful. So we work with what is there, but usefulness comes from what is not there. Or you might say, what's there creates profit, what's not there creates usefulness. Or we sell what's there, but we use what's not there. I mean, this is a real conundrum, even in English. And where it gets me to is, rather than try to get people excited about energy efficiency, I should just market the side benefits, which are so valuable and very trans-ideological. And, it's like getting people interested in climate protection without having to talk about climate, just by speaking to their concerns in their language. But Leidy, let me go back to how you learned this from a 3-year-old.
Yeah.
Because in Asian tradition, there's a strong emphasis on child mind, original mind, beginner's mind, and cultivating this ability to let go of all your assumptions and preconceptions so you can see things fresh. Have you tried to interpret the bias against subtracting through that lens?
I've definitely tried to interpret it through that lens. I mean, first, before we give too much credit to Ezra, my son, I mean, he's a horrible subtractor. He's worse than I am at it. He just plays a lot of Legos. So this was the rare instance where he subtracted and stumbled upon it as a solution. But he does. So for this specific bias, I don't think it's relevant. It explains it, but he does come up with amazing new ideas in his designs because he doesn't have the, I guess the functional fixedness of like this, this object has to do this specific thing. And so I totally agree with that beginner's mind. And as an exercise for design students, right? How can we, when we're taking time to think about all of the different options we have at our disposal, how can we instill that beginner's mind? I think is an incredibly valuable thing.
Yeah, I teach this stuff at Stanford in a course called Extreme Energy Efficiency. And every class we do a puzzler, a group design exercise, small groups, in some unfamiliar arena. And it's all about, as my old mentor, Edwin Land, said, the people who seem to have had a new idea have often just stopped having an old idea. So let me take where I am here as a little example. You can see in the back a little piece of my passive solar banana farm where we're ripening crops 79 and 80 at the moment at 2,200 meters, where it used to go to minus 44 Celsius. While it's blizzarding outside, we munch tropical fruits. But what's important is not what's here, but what's not in the building, what we designed out, like the heating system. And it turned out we saved more money leaving out the heating system, just upfront cost, than we paid extra for the stuff that got rid of the heating system: super insulation, super windows, ventilation, heat recovery. Or out in the driveway, I've got a BMW i3. It's a carbon fiber electric car, so it's very lightweight because it's made of a material that was thought hopelessly expensive. But it turns out it's paid for by the smaller powertrain you need to move less weight, and by the radically simplified manufacturing. So you can make the car with a third the normal investment and water and half the normal energy, space, and time. So it was competitively priced, and they sold over 250,000 of them. And basically, they quadrupled the efficiency of the car at a very competitive cost. These kinds of examples play across all sectors, industry, equipment, buildings, vehicles, and yet they're very uncommon. None of my Stanford students, mostly engineers, have heard integrative design in any of their other courses, because I suppose there's this supply side bias. And Stanford, wonderful place, has hundreds of people doing great work in energy, but it's about 99% on the supply side. I think this is very widely true. Do your psychological insights help you see some paths to helping adults with this, Herman Kahn said, educated incapacity, to stop adding stuff and start leaving stuff out? I mean, we know in art, as in manufacturing, you can be additive or subtractive. Somebody asked Michelangelo, how did you sculpt David? He says, simple, I just chiseled away everything that wasn't David. Yeah. You know, how do your psychological results offer insight into how to spread a different way, the other way of thinking about design?
That's great. I remember, for me, the integrative design is something, when I learned of it from your teachings, indirectly, I mean, through your book and through some of your seminars that I watched online, that whole notion of tunneling through the cost barrier, right? So it's intuitive to try to add on these new interesting features, or even to rearrange some things. But that piece where you take out the mechanical system, that is the part where is a real aha moment. And that's the subtractive part. I'd say some things from our research that we found that offer useful insights are that reminders are really important. And that sounds like common sense. Like, of course, reminders help with everything. But in our studies, we give people that grid study, right? And we give them this simple reminder that said, hey, you can add or you can subtract. And it increased rates of subtraction, which, you know, again, reminders should increase rates of things, but it didn't increase rates of adding. And so what that was really powerful for our study was like, hey, this is a bias. It's bringing new ideas to mind, the reminder. And so that's something that we can take out into the real world. And I think that it speaks to the need for something like integrative design and the how you package that and get that out into the world so that people have that top of mind when they're going through the design process. I mean, the good thing is that these reminders work. The bad thing is we didn't really find any evidence that a reminder on the grid problem, for example, would translate to another type of problem where subtraction might actually be useful. So I think also you need to have these reminders that are tailored to the task at hand. And when you're thinking about subtraction, as you are now, because Amory and I are talking to you about it, think about the places where you make design decisions and how can you put in place reminders for yourself to just consider subtraction. So that's one. The other one is it requires time to think. And this is actually where it does tie back a little to that beginner's mind that you were talking about, Amory, is that, again, it's not that we can't think of subtracting, it's that our default is to add. And another damaging cycle here is that the more we're under cognitive load, right? The more that's going on in our brain, the more we rely on the default. So the busier you get, the more likely you are to add. And so the way we looked at this in our studies, we'd have the grid pattern up there, and then we'd have numbers scrolling across the bottom of the screen. And every time a 5 went by, you had to press an F. So, you know, it's just distracted designing, and people became more likely to add. So again, for our studies, great proof that this is a cognitive bias. For practicality, it says, hey, you need to force ourselves to take some time slow down, and that will make us more likely to think of subtraction. And so yeah, those are some of the ways that we could tap into its power practically in our lives. Yeah. Oh, you're muted, Amory.
Okay. Let me take the liberty of adding one more example I've found. Okay, it says I'm sharing. So half the world's electricity or a bit more runs motors, and half the motor power runs pumps and fans, which move fluids through pipes and ducts. Now, it is common to use skinny, long, crooked pipes instead of fat, short, straight pipes. The fat, short, straight stuff is shown here on the left, and that blue pump on the right looks like somebody slipped a decimal point, but it's all you need when you take out most of the friction in the pipes. And the friction drops as nearly the 5th power of diameter. So how fat should the pipe be? Well, the engineering textbooks all say to make the pipe just as fat as will pay for its higher cost from the saved pumping energy over the years. But this leaves out the capital cost of the pumping equipment, because the pump, motor, inverters, electricals all have to be big enough to overcome the friction. So when you optimize the pump or the pipe as a component, you're pessimizing the system. When you optimize the whole system together, you use fat pipes, teensy little pumps and motors, and the total capital cost goes down by an order of magnitude. Or
it got muted again.
I know I'm struggling,
Okay.
trying to do.
Oh, one more mute.
Trying to do several things at once, and
Amory's told me that he has to, one thing that stuck with me from one of our conversations while he's getting this back up, there was a comment about him reducing the amount of words he's using, but he finds himself having to rehydrate his writing because he's gotten so adept at pulling words out. And that's something that I've remembered from our last conversation. Okay, unmute one more time, Amory.
Strunk Rule 13, omit needless words. So on the right, the other trick we do in designing piping systems is to lay out the pipes first, then the equipment, not the other way around. You know, normally you put your tanks and boilers and stuff in some arbitrary, traditional, convenient place. Then you call in the pipe fitter to connect A to B. But by then, A and B have gotten far apart. Other stuff's in the middle. They're far apart. They face the wrong direction. By the time the pipe snakes its way across the space, all dressed in neat right angles like they treat it, teach us in trade school, friction is 3 to 6 times what it should have been with a straight shot. But on the right, you can see those tan chillers, instead of staying lined up in a neat row with right angle elbows all over, are staggered. Things kind of slide around, so most of all the elbows go away, and we're left only with rather shallow bends. And again, the pumping equipment gets smaller and the total capital cost goes down. It just looks weird. Now, when I work through such examples with clients, engineers on engagements, they get it instantly. And one of the interesting things about this is you could spread this kind of design, hydraulic design, just by seeing a picture of it. You don't need to go back to school and learn new theory. Basically, we're bending minds, not pipes. And you could, I mean, Peter Rumsey got some of his installers to do this kind of piping just by asking them to lay out the supply pipes as if they were drains. Because there's another part of their brain where they know if drains driven only by gravity have right angle bends, they'll clog. So you need no bends or sweet bends. Well, this is kind of interesting because if you could spread this kind of design, it could have a very big effect on, for example, climate, because when you save 80 or 90% of the pump and fan energy by making the pipes and ducts fat, short, and straight instead of skinny, longer, crooked, laying them out before the equipment, that could save about 1/5 of the world's electricity if everybody did it, or half the coal-fired electricity. And empirically, we find that the paybacks are instant in new build and typically under a year payback in retrofit. And yet this is not yet in any standard engineering textbook, any government study, any industry forecast, or any climate model. Why not? Because it's not a technology, it's a bloody design method. And most people don't yet think of design as a scaling vector, a way to make things big fast. But to practice this kind of design, you have to cultivate original mind and let go of how you know things are supposed to be done, because that's always how we've always done it. It's called infectious hepatitis. So I keep coming back to a wonderful story in the Nara period, but actually in China. A Zen master who's now named Nadin in Japanese was visited by an imperious official or a professor in different versions of the story, who said, "Teach me Zen," in Chan. And the visitor was really busy talking about everything he knew about Zen. And Nadin politely smiled and poured tea and kept pouring, and it overflowed the cup onto the table and ran onto the visitor's robes. And the visitor became quite agitated. And he said, "Stop, don't you see? It's overfull. No more will go in." Nadin stopped pouring and said, "You come here wanting to learn Zen, but how can you learn Zen unless you have first emptied your cup? Emptying the cup is the hard part. And once we do that, we're just full of possibilities for subtracting, for overcoming the bias Leidy has identified." I see in Tyler has said asked in the chat, how much computing would you save if, say, Windows were written better? And I used to think that could save an order of magnitude if we designed our software around a really terse, Linux kernel or whatever, but with the aim that every compute cycle is a needed and wanted one. So we wouldn't have all these unnecessary threads and processes. And I thought it would be an order of magnitude saving. There's some recent studies suggesting it could be 2 orders of magnitude. That's how bloated the bloatware is. And now that we're using mobile devices so much, this saves battery power if you're using fewer cycles to do what you really want to do. And that gets valuable.
I think one theme too, there was another question in there about what persuaded me to go down this path. And it's echoing what Amory's saying about design. I mean, I'm an engineer by training. I care about climate. I want the built environment to be better. And the technologies are there. And it's the design that isn't. And design broadly defined as how we change things from how they are to how we want them to be is something that we all do. And that's there's psychology there. It's not only psychology. There's a lot of group processes. There's a lot of standard practices, but at its basis, it's decision-making and problem solving. And so that's what persuaded me to go study some of these things. And I mean, I've got a list of study topics that I want to look at next, and some of them are from another, from Amory's integrative design inspired question is like, why do we devote so much attention to parts and not as much to connections, right? And so it's a version of that spoke wheel question, and I haven't figured out how to operationalize it yet into studies, but if somebody does, let me know. So I think that's really important here, is that design matters. Design is something that we all do. Let me share a couple of and we're talking about how hard subtraction is, but I think, also sharing some of the power, because it's been overlooked for so long. One of my favorite examples, and if you've read the book, you've seen this example. I start the book with it, but this is the Embarcadero in San Francisco, right? And one theory about why we add so much is because it's been better in a lot of cases, right? When there's no roads, it makes sense to add a road. But once you've got a built up city, there become more opportunities that, hey, maybe there's some subtracting that can be beneficial. And so the Embarcadero, one of the most visited places in the world, when we went to San Francisco, I mean, that was the first place on my wife's to-do list. We took my son down there. He's tying balloon monkeys, and it was great. You see the harbor seals. And then I remembered one of my students, Trip Shealy, had told me about this Embarcadero removal in San Francisco because he knew I was interested in subtracting. And I was like, this can't be the same place. But sure enough, this used to be covered by a double-decker highway. And, getting back to the point of we're all designers, engineers know how to remove a highway, but engineers are just doing the bidding of what people want. This double-decker highway lasted there for 40 years. They put it to vote, and the citizens voted 2-1. No, we've got to keep this highway. We need to, serve the vehicles. It's unthinkable to get rid of this thing. And it wasn't until the earthquake in 1989 that the highway got damaged. People couldn't use it, and they saw that people found other ways to get around the city, that public sentiment changed enough that the planning commission was able to force this through basically on a 6-5 vote, and they got rid of the double-decker freeway. And by the way, that whole planning commission and the mayor got swept out because people were still mad that they got rid of the highway in the immediate aftermath. And now you can't find anybody who thinks it was a bad idea to subtract that thing. So there's power there. And some of these are new opportunities. I also think, the city scale, while we're looking at this cityscape, there was a good point there about the fences, right? So this idea that to subtract something, you need to understand the whole system. To add something, you can just add it on, right? Bacon makes everything better. I'm a vegetarian, but the adding, you don't have to understand the system. Subtracting, you have to understand the system, and you have to give a little bit of benefit of the doubt to people who came before, right? And think, okay, they put something here, there must be a good reason for it. So it requires a little bit more work. And then the other example, since I been told by my wife that my daughter is going to get a complex if she doesn't get mentioned in some of these stories. This is the balance bike, another one of my favorite. So she is now 3, the age that Ezra was with the epiphany. But this balance bike, I'm mad that they didn't have this when I was growing up, because you can zoom around on this bike basically as soon as you can walk. Josephine here, she can go faster than I can run now on this bike, and it gives her this incredible sense of independence, freedom of movement that 2 extra years compared to what happens if you're waiting for a pedal bike. The whole innovation here was to remove the drivetrain. And bikes, somebody will post in the comments that the first bikes didn't have pedals, but the first bikes weren't rideable by toddlers. Bikes have been in use for a long time. The last 100 years, there've been all kinds of inventions in bikes, fatter tubes, shock absorbers, mountain bikes. Nobody thought to remove the pedals and the drivetrain until Ryan McFarland, who's the founder of Balance Bike, and he was thinking through, and he really nicely details his design process. You can Google it, or it's in my book too. And he's going through this steps of thinking is basically the same as Amory removing the mechanical system from his house. And Ryan McFarland says, "Oh, I was trying to lightweight it, and then I realized, what if I just get rid of the pedals? And then all of a sudden, you've got this product that can be ridden by a 2-year-old. And the last thing, and then I'll shut up. I think one general principle for subtracting things is you've got to zoom out a little bit. You know, some of the times you think something is essential, and if you zoom out and realize that something else that is going on in the surrounding situation can provide that function. In this case, it's the toddler. I mean, it's totally unthinkable, right, that a 2-year-old can balance on a bike, but they can. If you take away those pedals, Josephine can balance on that bike and ride as fast as she wants. And so by considering the human, you realize that you can subtract some of the mechanical thing in this case. So again, two hopefully inspiring examples that, because subtracting has been overlooked for so long, there's some real low-hanging fruit out there to tap into.
Actually, it's just eye-level fruit, because if you look up or down the tree, it's all covered with fruit and it keeps growing back faster than we can harvest it. But you just made a very important point that I think, for me, echoes Dwight Eisenhower when he was still general, not yet president. And he said, if you can't solve the problem, enlarge it. That is, normally when we're given a tough or a wicked problem, our instinct is to chop it into little pieces that are more bite-sized, but that loses all the connective tissue and it makes it harder. But instead, if you move the system boundary out until it encompasses everything the solution requires, you'll get much simpler, better solutions. So this is a very powerful, simple concept. I hear it in Silicon Valley as, you know, if you can't solve the problem, make it bigger. And very few people do that, because perhaps it's too simple. But I think it's very akin to the notion of subtractive solutions. Leidy, where do you go from here with your study of bias against subtraction and how to encourage subtractive thinking in an original mind?
I hope that things like this are useful. I mean, so I will share with as many audiences as I can the scientific findings, and then hopefully the implications from the scientific findings. Again, those reminders and figuring out how to get this into people's design toolkit is a big motivation for me. And then on the scientific front, I'm trying to understand more of these some of these other fundamental principles for how we design. So I mentioned before, you know, this like parts relationships thing. Also, you know, design on a temporal scale. How do we think about time when we're designing? I mean, so many things seem to be, you know, designed for a 400-year lifespan when it's only going to last 20 years, or vice versa, designed for a 6-week lifespan and it should last 6 months. And so figuring out how to kind of align those expectations is something that psychologists spend a lot of time on, but not really in a design context. So those are some of the things that I'm really excited about. And, you know, personally, I think that there's huge potential for this with climate and sustainability and planetary boundaries. And so, you know, trying to get this into that conversation. I mean, the most recent IPCC report has a little bit more on design and systems, but it's still, you know, like Amory, you said before, it's this focus on technology that is in a lot of ways gotten us into this mess. It's that classic example of trying to solve a problem with the same mindset that created it, right? So how can we shift that mindset fundamentally as a leverage point for climate change and some of these other related issues?
Well, in integrative design, we found a set of now well proven solutions developed over almost a half century that apply in about every application in every sector for making the energy efficiency resource several times bigger than had been thought, but also cheaper, and often with the same increasing returns that we see in consumer electronics or renewable energy. So the more you buy, the cheaper it gets. So you buy more, so it gets cheaper. This turns out to be not easy to spread. Again, because design falls through the policy cracks. It isn't a technology. It's funny, Stanford just put out an RFP for some accelerator grants in its new School of Climate and Sustainability. And the categories you could apply in didn't include anything on the demand side. They were all about different kinds of supply. But there was another other category, so I used that. So I actually have now, this 18 hours of great cases that I want to put on edX or YouTube and spread it to millions around the world for free. We're looking for opportunities to teach the teachers, so that becomes a scaling model. Teaching a Stanford class is great, but it's linear, it doesn't scale. I'd like to, as some people have suggested in the chat, get integrative design into design software. It ought to coach you to that result. And actually, a very large maker of design software had the nice idea that if you want to opt out of being coached to that solution, you have to press the stupid button. You have to choose the bad solution. Otherwise, the software will help you make best easy. I want to get to the people who actually install a lot of this stuff, plumbers and pipe fitters, sheet metal workers, and so on, who have very good union training but doesn't yet include this sort of thing. I'd like more industrial collaboration. We found, for example, that the chemical company, one of the biggest in the world, that's probably bested in enculturating efficiency and has saved over $19 billion on a $1 billion investment, saving heat and molecules, isn't yet doing the simple pipe stuff, but they have a lot of pipes and pumps, but they just hadn't thought of it. So there are altogether something like 14 or so scaling vectors I'd like to pursue, and would love to have advice and help and collaboration from anybody that wants to basically raise an army of practitioners and enablers for, to put it impolitely, the nonviolent overthrow of bad engineering.
Well, Amory, I think you have a lot of adherents in the chat over here, and I would love to make sure we take some time for questions. Do you have one more question you want to ask before we switch over? Are you ready?
I'm fine.
Okay, cool. So the first question, there's a lot of really interesting conversation, if you haven't been following, about across disciplines, about how to apply this across disciplines, including a lot of chatter about software and code development. David Brin is making comments about writing, which are not questions, but they're really, it's so interesting and fascinating to see how this applies across all of these different fields and subjects. Okay, so Bobbin Teagarden has the first question about simplification of the world. Bobbin, are you there? I think this is more of an inspiration or an idea, but she says, could we reward the world for simplification? And what kind of rewards would that be? How would you incentivize that?
I can say how not to. Oh, well, Amory, you take this one. You start it, then I'll fill in the details, because natural capitalism, I feel like at a grand scale is very much about this.
But I couldn't hear the question because of bad sound quality. I'm sorry.
Oh, the question was, how would you reward the world for simplification? Like, how would you restructure our kind of like built-in innate reward systems to encourage simplification over addition?
Well, I don't think you do it in the abstract, but as the German passive house movement showed, which was partly inspired by this building, if you can produce better comfort and health and safety at the same construction cost, there gets to be a demand for it, and people that deliver that get rewarded competitively. And you can draw out the same example in every sector and use. I do most of my outreach through competition, helping early adopters practice integrative design and get their competitors' attention by beating them in the market. But we also need other layers of reform. For example, paying our architects and engineers for what they save, not what they spend, because the compensation is completely perverse. Rewarding utilities for cutting your bill, not selling you more energy. We get that wrong in 26 of the United States and a lot of other places.
Mhm.
And there are also 60 or 80 real obstacles to buying efficiency, whether achieved by integrative design or otherwise. Each can be turned into a business opportunity, but each can also be a showstopper if you ignore like one of the 24 parties in the commercial real estate value chain, all with stunning perfection, rewarded for inefficiency, penalized for efficiency. So this work does require relentless patience and meticulous attention to detail. It's, you know, the cornucopia is there, but it's the manual model. You actually have to turn the crank.
All right, next question comes from Chris Apfel. Chris, are you there? He
Yes,
said,
I am.
oh, go for it.
So I was asking the question, what made you starting on that? And with a Wharton MBA background, I'm actually now asking myself, well, how can we bring this into the world? How can we commercialize this? How can we make sure that people are benefiting from it? And I think what's really this is it's a question of design, smart design, and smart design is often not honored and appreciated until it's there, and so it's especially in a group, I have often difficulties when we are building something. Everybody wants to add certain components and wants to add certain ideas. And cutting back is really painful to make it simple and straightforward and beautiful. I'm wondering whether one actually needs to act on branding. I downloaded your nature paper, and I've now downloaded the Audible book on Subtract on my phone. So I'm actually looking forward to really learn about this. One of my ideas that I actually had, and I'm wondering whether that could help, is I think 2 days ago, there was a discussion why there is so little interest in STEM. And I was made in Germany over half a century ago. And I felt that when I moved to the US, there are much less people interested in STEM. And it's because STEM is not as attractive, and it's not it's in the culture here in the US, it's not appreciated as much. I'm wondering whether your Subtract concept could be marketed more effectively by changing some of the words that have a more positive connotation. I'm thinking in this case about ingenuity. That's kind of the term that came up to my mind, and so the genius that comes up with a simple solution, like how do you solve the Gordon knot? You just cut it through, right? And you had this example with your daughter, with this bicycle, push bike. This is actually a push or bike in a way, and so I'm wondering whether there's any way you can capitalize on that with the concept of ingenuity, fostering ingenuity. And I think it needs to have a really strong positive word where it looks that it makes the world simple, clean, kind of Zen-like. And I think that's also the reason why Apple has been so successful, because it was simplifying the world, bringing peace, kind of like a Zen meditation into
Chris,
the world.
I'm going to have to cut you off because I want to make sure we have time for Leidy
Sure.
to answer your question.
It's an awesome question.
But it's a fantastic question. So the question is, go ahead.
Yeah, the balance it's important. I mean, I put that on the title of the book, knowing full well you can go machine learning evaluates sentiments around words, right? And most words have a neutral valence or a positive valence. Subtract is one of the very few that has definitely a negative valence around it. So people, it's just a little off-putting. It's not as bad as moist or something like that, but it's still bad. So I totally agree that there's a marketing opportunity here. I do think that there's also one of my goals, and I say this in the book, is like, if, can we even make change the valence around subtracting so that it becomes viewed as positive? But in the meantime, definitely reframing. And there's a designer in there, Kate Orff, I talk about, and she does a lot of these like kind of natural landscapes. She's a landscape architect, but she does a lot of removal. And she never says subtract, but she uses words like clean, reveal, carve. And so, yeah, the marketing is incredibly important. I also think that one of the messages that, since you're interested in trying to figure this out, is this is harder, and people don't like to be told that something is hard. And so if there's some way to convey that it's harder, but that it's hard things are fun, that's another kind of marketing challenge for this as a design approach. But brilliant questions, Chris. Thank you.
Okay, so Ty Carlson has the next question.
I have a lot of comments. One, I want to just say thank you, because it's a very interesting discussion. I think the question is how do we incorporate these into the daily work environment, and how do we add these features in at the beginning? So as you design for, as people design for recycling, how do we design for simplicity? And how do we design something and then take that design and put it on the wall and say, okay, remove 10% of this, and how much features, to make it more efficient and more elegant. I think that's things we just need to think about. But comments in that space or success stories would be interesting to hear.
I think it's a cultural question. Somebody said you can only get to simplicity through complexity. And then Einstein said everything should be made as simple as possible, but not simpler. And he added, I wouldn't give a nickel for the simplicity on this side of complexity, but I'd give my life for the simplicity on the other side of complexity. That's a worthy challenge. And I think Saint-Exupéry got it exactly right when he said perfect simplicity is not when there's nothing left to add or when there's nothing left to take away. You get there partly, as Gregory Bateson said, by seeking the pattern that connects. Or Mike Corbett said, you know when you're on the right track when your solution for one problem accidentally solves several others, but avoiding problems is a lot better than solving them. And great designers know that all the really important design errors are made on the first day. That's when you're setting your system boundary and scoping out the stuff you should probably be including.
Amory and Leidy, this is really compelling stuff. I love this. Thank you very much.
Thanks, Todd.
Right.
I would add some.
Yeah.
Do I have time, Barrett? And these quotes have existed throughout time. There's Lao Tzu has one about adding, and it's attributed to him, but to gain knowledge, add things every day. To gain wisdom, subtract things every day. And in terms of practical tips, we talked about reminders. We talked about things like integrative design that, put this front and center. I'll also just blunt rules. I talked to, I think British Columbia did this, where if a legislator wanted to bring a new law, they had to also come with two that were on the books that they were going to get rid of. And that's a very simple thing that forces subtraction to be part of the process.
Yeah,
Excellent.
It's interesting to watch, going through the legislative process as well. It's like that's another area where it's all about addition, adding new laws, adding new laws, adding new laws. And it's very rare that you would see lawmakers go through and remove laws. Extremely rare. The entire process is designed around adding. And
friction applies here too. So Amory used friction in terms of pipes, but there's a great quote, Daniel Kahneman, kind of paraphrasing Kurt Lewin. So like this is the father of social psychology and Kahneman Nobel Prize winner for judgment and decision making. And Lewin said that in systems, there's a good way to make change and a bad way to make change. And the bad way is to add impelling forces, to add incentives, or to add rules. And the good way is to remove these barriers. And the reason it's the good way is because removing the barriers also relieves tension in the system. So if you think about it with laws, if you add another law on to a system that already isn't performing optimally, all you're doing, it might make it a little better, but the fundamental tension is still there. To relieve that tension, you need to subtract some things. So in some cases, it can actually not just be an overlooked and another option, but the better option for making change.
Thank you both so much. We are out of time, and I want to make sure we have time to get to our next session. This has been a fascinating conversation. Amory, thank you for suggesting it. And I look forward to seeing all the ways that reductive design is better implemented into the companies and products that the FIRE community is building this year. Hope to see all of you there. Thank you so much, everyone.